Hi, this is Shreya, and I'm from the team Oxy-gen. My teammates include Tanya and Naveen. So, the mission statement of our project is to achieve Industry 5.0 in supply chain management, especially in the planning part of it, by implementing AI and AR tools. So, as you can see over here, these are the components of the supply chain. You've got planning, sourcing, inventory management, logistics, and production. Planning especially deals with preparing the manufacturing units as well as the workers for the particular product that they have to be manufacturing or producing in the due course. Now, in the past couple of years, especially due to the coronavirus pandemic and the new protocol, manufacturers don't have enough workers or human resources to help with the production. But with the few that they have, the problem is that those few are not experienced enough to ensure or to achieve the amount of precision that is required in the finished products. So we aim to tackle this particular issue. So over here is a device which is called as the universal testing machine. This device is used in almost every manufacturing units in this world. Irrespective of the domain that they specialize in, all of the manufacturing units have got a universal testing machine. Now, what exactly does this machine do? Any product that you have that has to go under testing meaning compression tests, tensile tests, strength tests, or strain tests, any parameter that has to be tested has to undergo a test in this particular machine. So, like I said, there are millions of tests. A few are depicted over here. Now, the problem is that people have to memorize what test has to be used for what use case scenario and how do you perform this test. So it's very confusing if you ask me. So to tackle this problem, to help train the workers in a better manner, to ensure the amount of precision, we propose a solution. The solution is this. We plan to deploy an augmented reality tool which is equipped with artificial intelligence. This tool, as you can see over here, is to train the workers using several use case scenarios to be prepared for the real-time work. It is to simulate worst case scenarios so that the manufacturing plants and the supervisors and the companies can be prepared for any worst come scenarios by having contingency plans. And it also helps to avoid human errors and improve precision and therefore productivity. So as I mentioned earlier, the value proposition of this entire product goes like this. To learn and understand several use case scenarios, to train workers and facilitate them to adapt to any situation, the proposed technique allows factories to simulate worst case scenarios and be prepared with contingency plans. It is user friendly and it is easily adaptable. Like I said, the machine is used in absolutely every manufacturing unit in this world, irrespective of the domain that they specialize in. Therefore, this product can also be used across various domains. And another thing is that it helps to achieve the break-even point very quickly, thereby ensuring profits for the companies, and it also allows them to keep up with the growing demand. So the materials required for this is an Instron machine, which is a UTM machine. Unity is a software that we use for augmented reality. SolidWorks is a software that we use to create CAD models that will be given as an input into this Unity software for realizing this particular thing, as you can see over here. Tablets, as I showed in the picture earlier, will be the first phase of this project. And Microsoft HoloLens will be the second phase of the project, as you can see over here. So how exactly does the solution work? So usually learning goes like this. People study from books or from professors directly. but we aim to deploy tools over here, that is some tablets or Microsoft HoloLens or any VR and AR tools. So the students or the workers will engage with this tool, which is connected to the cloud data set, which has all of the simulated scenarios over here, which will be overlooked by this instructor or supervisor who will go through or overlook the training process of these workers. So the testing methodology goes like this. As you can see, there are several workers from several industries over here. This is to ensure that we have a holistic approach to the entire testing process. So the column over here is the experience rating. We will ask all of these people to rate their experience with this particular solution on a scale of 1 to 10. The training time, that is the amount of time that they have taken to undergo the training process. The number of errors that they have encountered in the entire learning and the testing process. The variation in the results that they have got. The observer score is scored by the supervisor, like I mentioned earlier. He or she will give a score to all of these people based on their learning on a scale of 1 to 10. And this will be a test that will be conducted at the end of their training process by giving them untested scenarios so as to see how much knowledge that these people have got in this entire training process. And so the milestones of this project goes like this. By April, we aim to complete the application. By May, we aim to complete the application with the test results by the testing methodology that I've mentioned in the previous slide. And by June, we aim to finish the final prototyping. So this is the proposed solution, which will be really good in helping manufacturing industries to train their workers and to achieve profits and maximum precision.